Okay, this next question. As you read through here, quite honestly, there's some things here that come from the momentum unit that we have not studied. And so that's why there's only two questions here, is when it was originally printed on the AP test, um, there were more questions. But we don't have the ability to do those because we haven't learned momentum yet. So we are just going to do questions A and B. Okay, if we look at an LOL chart, when the box is at the top, it does not have any kinetic. It has a lot of potential. When it is at the bottom, so it's going to come down, it's going to come down here at some point, that box is, that's the M box. And at that point, it's going to have a lot of kinetic, but no potential. That's how we're going to set up our equation. So we're going to use this LOL chart to say 0 plus MGH, or again, MGY is what they use on AP, so we can use that, is equal to 1/2 mv squared plus 0, because there's 0 potential here, and there's 0 kinetic here. We've done these problems enough, hopefully, that you know you can cross out your m. That's not necessary. And so we have g times y is equal to 1/2 v squared. We are being asked to find the height, which I've labeled as y, and actually on this diagram, they labeled as h, so I should have left it as h. In any case, we need to divide by g and solve for h. So I do a little bit of algebra and I get that v squared equals g times 2. You could call it 2g. Now, they also tell us that at the bottom it has a velocity of 3.5 times the original velocity. So let's go ahead and plug that in. And then as we simplify this, we multiply this, we take it to the second power, we divide by 2, we should get 6.125. So here's our h. All right, that was question A. Question B, the larger block sides the distance of d before coming to rest. Determine the value of the coefficient of kinetic friction between the larger block and the surface on which it slides. All right, so block M is going to hit block 1.5 M. Block 1.5 M is going to go, and we need to find out the coefficient of friction. This is a little bit, actually a lot, like the Hot Wheels lab that we did. So here we are on part B. So whatever speed it had at the bottom of the hill is going to be changed into work because it's going to come to a stop. So this is the speed at the bottom of the hill. It's going to be changed into work. All right, we need to plug in some information. The mass of this object is 1.5 m. So we're going to use that. The velocity, they tell us the velocity of this block is 2 times VO. All right, force is, in this case, we're talking about frictional force, right? That's what's bringing it to a stop, is the frictional force. Well, friction is mass times gravity times mu. So we need to look at all of those options in there. The mass is also 1.5 capital M. That's going to cancel out. That was 1.5 capital M. It cancels out with that one. So now what we have is 1/2 times 4VO squared is equal to G times mu times, this time I'm using a capital D because that's what they used in the problem. They used a capital D in the problem. I need to solve for mu. This question was all about mu. So I'm going to divide by G capital D. So I do my math and I do my division and I come up with the mu. The mu value is 2 times V squared over GD.